Okay, next we are going to see how to find a limit at infinity. So as you can see from here, from this summary, we have already seen how to do case 1, the substitution, case 2 where you get 0 over 0, case 3 where you get a over 0, which is the answer is positive or negative infinity. For these three cases, make sure that this is x approaches to a. Okay, so for this video, we are going to proceed to the case 4, which is we are going to see limit x approaches to positive or negative infinity. Okay, as I said in the previous video, when we have a over infinity, the answer is equals to 0. Okay, so let's see. Okay, so this is limits at infinity, case 4, which is when you have limit fx when x approaches to positive or negative infinity. You substitute, you get a over infinity, and the answer should be equals to 0. So here is for x approaches to positive and or negative infinity. So the first thing that you have to do when evaluating your limit is to see that x approaches to a constant a or positive or negative infinity. So let's see here, we have if the function fx approaches L as x increases without limit, then limit fx when x approaches to infinity is equals to L. Okay, so what does it mean from here? So let's see if we have a graph here. Let me do, okay, alright, so we have a graph here and then you have a function like this. Okay, let's see if you have a function like this. So if the question said limit fx when x approaches to positive infinity, this is a positive infinity. Okay, so limit fx when x approaches to positive infinity. That means your the value of your limit is equals to L, which is this is your y equals to L. Okay, this is y equals to L. Okay, so ini sebenarnya sambungan dia di sini ini di sini. If you have one more graph, let me draw one more graph here. Let's see if you have a graph like this. Okay, so here is your y is equals to m. Let's say this is y equals to m. So when fx, kita tulis kat sini lah, limit fx when x approaches to negative infinity is equals to m. So negative infinity is here. Okay, this is your x, negative infinity, that means to the left lah. Okay, so your graph should be, your function should be looking like this. This is negative infinity. X approaches to negative infinity. So the value is y equals to m. Okay, so maybe macam tak faham, it's okay. We can just go straight to the example here. So as what stated here, we have limit 1 over x to the power of n, a constant. When x approaches to positive infinity, we are going to get 0. Okay, when we have 1 over x to the power of n, a constant, when x approaches to negative infinity, we also get equals to 0. Okay, so let's see example 10. We have a function fx equals to 1 over x squared. The question asks to find limit positive infinity and negative infinity. So first, make sure you know how to draw this graph here. So the graph should be looking something like this. We have here one, ini pula here, and and we have another one here. Okay, alright, so this is 0. So when you want to find limit fx, our fx is 1 over x squared when x approaches to positive infinity. So to the positive infinity is here. This is x approaches to positive infinity. So the constant here is, this is the value of 0. Okay, so this equals to 0. So if you have limit x approaches to negative infinity, which is our fx is 1 over x squared. So here is x approaches to negative infinity. So the answer is still equals to 0. Okay, so this is what we mean by this note here. Okay, so let's just go straight to the example, or make sure to know that when you have a limit x approaches to positive or negative infinity, if you have a over infinity, you are going to get 0 there. Okay, sorry, salah kat sini. Kalau kita ada a over infinity, the answer should be 0. Okay, so let's see if you have limit x square plus 3 when x approaches to infinity. So there is no irrational value here. So let's say if you substitute the infinity value into here, infinity is a big value, okay? Nombor yang sangat besar. Kalau kita substitutekan infinity kat sini, kita squarekan lagi, okay? Obviously dia akan jadi lagi sangat besar. Kita tambah lagi dengan 3, which is a small value of 3. So it doesn't affect anything. So that means we can assume that when x approaches to positive infinity, we know that x squared plus 3 also approaches to positive infinity. So we know that limit x squared plus 3 when x approaches to positive infinity is equals to positive infinity. Okay, kita just substitutekan the value of infinity into x. Infinity ialah nombor yang sangat besar. Kamu letaklah contohlah 1 juta. 1 juta pun belum cukup lagi. Infinity is a very big value. Okay, so let's see example B here. We have limit 1 minus 5 over x when x approaches to negative infinity. So here we will have limit 1 minus 5 over x when x approaches to negative infinity. So what are we going to do here? Okay, let's say kita pecahkan. We have limit x approaches to negative infinity minus limit 5 over x when x approaches to negative infinity. Okay, a constant here. Okay, tak ada nilai x pun dekat sini. So it's gonna be 1. So here you have 5 over infinity, which is we are going to get 0. So the answer is equals to 1. Okay, so the same thing works here. We have limit 2 over x minus 3 cube when x approaches to positive infinity. So first, let's see if you substitute the value of infinity here. Infinity minus by 3. 3 is a very small value compared to infinity, which means the answer is still positive infinity. Okay, the answer is still positive infinity. Kita powerkan lagi dengan 3, so it is still going to be positive infinity. So, we can assume that when x minus 3, let's see, when x approaches to positive infinity, x minus 3 cube also approaches to infinity. So therefore, we will have limit 2 over x minus 3 cube when x approaches to positive infinity, we are going to get 2 over infinity, which is the answer is 0. Okay, alright.